kinematics and graphing. In kinematics and graphing, there's many components that go along with it, and we'll be going through so you can have a more base knowledge on graphing. So uniform motion is traveling in equal displacements in equal time intervals, neither speeding up, slowing down, or changing direction. For example, in distance over time graphs, we'll have a simple y equals mx plus b line, and in velocity over time, it will have a horizontal line since speed doesn't change when it's going constant. And acceleration over time, the acceleration will be zero. Non-uniform motion is unequal displacements in equal time intervals or vice versa. For example, in distance over time graphs, it will have parabolic lines. Velocity over time will have y equals mx plus b lines or lines of different slopes. And acceleration over time line will go up or down since acceleration is changing, or horizontal is speed isn't changing. Instantaneous velocity is velocity at a particular point, and instantaneous acceleration is acceleration at a particular point. Average velocity is change of position divided by change of time, which is also slope, which is the slope of distance over time. And average acceleration is change of velocity divided by time interval of the change, and which is also the slope of the velocity time graph. Calculating average velocity in uniform motion is average velocity equals instantaneous velocity by finding the slope of the distance over time graph. In non-uniform motion, average velocity equals slope of a secant, which is also a line connected by 2 points. And instantaneous velocity equals slope of tangent, which is also a line passes through 1 point at an angle of the curve. Velocity in time graphs and acceleration has components of non-uniform motion, which is a straight line up, which is constant acceleration, straight line down, which is change in acceleration, or horizontal line, which is no acceleration at all since it's going constant. And calculating accelerations is a slope and velocity time graph equals acceleration. The y-intercept of velocity over time graph, displacement over time graph, and acceleration over time graph, and the components of it, v represents the object's initial velocity constant, and calculating accelerations is a slope and velocity time graph equals acceleration. The y-intercept of velocity over time graph, displacement over time graph, and acceleration over time graph, and the components of it, v represents the object's initial velocity, d it represents the object's initial position, and a represents object's initial acceleration. The area under the curve of a velocity time graph, the area under the curve equals the displacement. The coinciding curves, this means that both objects have the same velocity, displacement, or acceleration depending of the graph. Area under the curve of the acceleration over time graph equals velocity. The scalar is a measurement with no direction, which is speed, and a vector is a measurement with direction, which is also magnitude, which is velocity. Adding vectors cannot add vectors with different units, and the equation for velocity time graph equals vf equals at plus vi, and the vt slope means acceleration. And this is a demonstration of a distance over time graph. To explain it, in this little section right here, it's accelerating because it's barely starting from time 0 to going up, so it's increasing, which is also increasing the velocity. But when we come here, it goes at a constant velocity, which will be a constant speed, and acceleration will be 0. And when coming down here, it's decelerating, so it's just slowing down. And as stationary, that will be the end point of the distance traveled in a distance over time graph.
Okay, this is the average velocity and what the instantaneous velocity. So it's the change in displacement over the change in time, and this is a demonstration of it with the displacement versus time graph. Okay, today we're doing a graphical problem on okay, here's the problem. Consider an object that moves with a constant velocity of 5 meters per second for a time period of 5 seconds, and then accelerates to a final velocity of 15 meters per second over the next 5 seconds. So this is a velocity time graph, right? And in order to find the displacement, you find the area under the graph. So you can break this into two parts, because the shape you can't really find the area. So you know that this is a rectangle and this is a triangle. So the triangle is, for the rectangle, you find base times height. So it's area, so you know the base is 7 seconds and the height is 5 seconds from here to here. So it's going to be 50 for the area equal meter. And then for the triangle, it's going to be 1/2 times base times height equal the area. So 1/2 times 5, which is for the base, and the height is going to be 10. So 50 times 1/2 is 25 meters. So that's displacement for the triangle. So, and then the total displacement is when you add these two together, which is 75 meters. That is the total displacement. And using the graph can help you find the total displacement.